question is very important. Like, you know, understanding time and space complexity is very, very critical, as you will be needing this tool throughout your DSA journey, right? And the theory part of it is not very important, to be very honest. If you are able to look at code and you are able to tell the time and space complexity, then we are good. Okay. Yes, which case is left? I think it's a 20 minutes topic. We will try to cover it up. Okay. But yeah, let's see. Okay. So let's start. What is the time? It's 8:03. So we can get started. Okay. Cool, guys. So I think we can start. Just give me 1 second. Is my PPT visible to everyone? Okay, great. So let's pay attention, guys. And okay, I have also, you know, I am thinking of introducing polls for you all. Let's see how it goes. Okay. So, you know, we can have polls in between to understand how many people are understanding, not understanding, because chats don't give a very good idea of how much people have understood versus how many have not understood. So I am thinking of introducing polls also. So let's see. Okay. Okay. Karthik, we have done it yesterday. Okay. Please look at the video. We have already solved the question yesterday. Okay. So let's get started with the concept of time and space complexity. Okay. So first of all, before even I start with the theory and all the problem solving of time and space complexity, first of all, I need to understand what exactly is time and space complexity, or why are we even studying this topic in the first place, right? So think of it like this time and space complexity analysis. Let me give the heading like this. The time and space complexity analysis is a tool. Okay, it is a means via which you can evaluate the efficiency of your program. Okay, so what do? We basically write code, right? We write multiple algorithms and we write multiple codes to do our task, right? So time and space complexity analysis is a matrix. Okay, it is a tool, or it is a matrix which will help us to evaluate the efficiency of your algorithm. Okay, how good is your algorithm versus how bad is your algorithm? Time and space complexity analysis can help us to decide that. Okay, so why do we study time and space complexity analysis? So that we study this, so that we can evaluate algorithms. We can evaluate our algorithms. So guys, I will do everything. नहीं कराया switch case, पता है, करा दूंगा. ठीक है, don't worry. Let me continue, right? We will do everything. Okay. So time and space complexity analysis is a tool, or think of it like it is a matrix. Okay, it is a matrix, or it is a parameter via which you can evaluate the efficiency of the algorithms that you write. Okay. See, think of it like this is person A. Hello. Am I audible, guys? Are you able to follow along? Or is my voice breaking? Okay, it's fine, right? Okay. So I will repeat what I have said till now. I haven't actually, you know, said a lot till now. So we are going to study today time and space complexity analysis. And I am telling you, why do we even want to study time and space complexity analysis? Because time and space complexity analysis, think of it like it is a tool, okay? Or it will give you a matrix. Okay, the time and space complexity is a matrix via which you can evaluate the efficiency of the code that you write, or you can evaluate how good or bad is your algorithm. Okay, so think of it like this. Suppose there is person A, okay, and he has written a piece of code. Okay, he has written a piece of code that is doing some job. Okay, now person B, there is another person B. Okay, he has also written a piece of code, and his code is also achieving the same job. Okay, so person A has used a different algorithm and person B has used a different algorithm, but the end goal of both the codes are the same. They are achieving the same task at the end of the day. So if I want to compare, if somebody asks me, is person A's code better or person B's code better, भैया समझने का ट्राई करो. मैं बोल रहा हूं टाइम एंड स्पेस कॉम्प्लेक्सिटी एनालिसिस हम लोग क्यों पढ़ रहे हैं. आई एम जस्ट रिपीटिंग इन हिंदी एज वेल. सो टाइम एंड स्पेस कॉम्प्लेक्सिटी एनालिसिस से मेरे को एक मैट्रिक्स मिलेगा, या मेरे को एक तरीका मिलेगा जिससे मैं बता पाऊंगा which code is better. Okay, or I can evaluate the efficiency of the code that I write. Okay, Now, let's say that, two people are writing code. Person A has also written a piece of code and person B has also written a piece of code, right? Now, both are doing the same task. Both are doing the same task, right? But there has to be some metrics via which you can judge their code. See, we should not judge each other's code, right? But person A is using a different algorithm and person B is using a different algorithm. So if I want to compare the two algorithms, ki boss, is person A's algorithm better than B's, or are they both the similar algorithms, or is person B's algorithm better than person A? So how do I compare these different algorithms of person A and person B? That is where I will be taking help of time and space complexity analysis. Via this analysis, I will generate certain metrics for person A's code. I will generate the certain metrics for person B's code. And then I will compare the metrics and I will tell you whether A's code is better or B's code is better. Okay. Is it making sense why we are trying to study time and space complexity analysis? Think of it in simple terms that this is a tool that will help you to evaluate the efficiency of the code that you are writing. As simple as that. Okay. Let's move further. So this time and space complexity analysis, as the heading only tells, it will be judging your code on two parameters. Can anybody guess from the heading? Like, what are the two parameters on which we will be judging our code? Anybody from the heading? Running time and space, right? So see guys, there are two critical parameters. There are two important critical parameters via which we judge any code. Number one is the time taken by the code to run. And number two is the space that the program occupies in memory. So time and space are two very, very important critical parameters via which you evaluate or check the efficiency of a person's code. Now, why is time and space important? You will ask me, why is time and space important? And these are intuitive. These are intuitive yourself. See, Ankit, not exactly number of lines, but we actually see how much time my algorithm is taking to run. Okay. Now, first of all, why is time an important factor? Why is time? Now, this is very natural, right? If we are developing applications or we are writing our code, we always want ki boss, my code should run quickly and I should get the output in minimal amount of time. Everybody wants their code to run fast and the response to be faster, right? So what is a good code? What is a good code? Can I say a code for which the response time is less? Response time should be as low as possible, right? The codes that are running in short amount of time, they are more better. So time is definitely a very, very critical parameter because everybody is out of time and we want that boss, the code should run as quickly as possible. So definitely time is a very, very critical, resource that we have to evaluate. What is the second? The second one is the space. Okay. Whenever you write any code, okay, whenever you write any program or whenever you write any code, right, that actually occupies some space in your RAM. Okay, the code that you write, that actually consumes some amount of space in your RAM. And what consumes space? The variables that you write in your code, the data structures that you declare in a code, right? We all use variables. We make arrays. We will be making stacks, queues, and all these data structures in the future. So all of these things that you write in the code, they will be taking some amount of space in the RAM. And what do you want to do? I want to minimize the space that my code takes. Why? See, boss, what is RAM made up of? RAM is made up of semiconductors, silicon wafer, right? And if you know, silicon is very, very expensive. Long story short, you have very limited amount of your primary memory. Okay. The RAM is very, very limited in space. So whenever you are running a program, you want the program consumes as less space as possible so that other programs can also run in the RAM. See what I'm telling you, think of it like RAM is like a block, okay? And any program that you run, that will occupy some space in your RAM. So if my program occupies lesser space, then I can load multiple programs in my RAM. I can at the same time load multiple programs in my primary memory. But if my code is taking more space, then maybe you cannot load multiple processes in your RAM. Okay. But a simple way to understand will be, boss, the physical memory, the RAM and the ROM that we talk about, they are physical memory, right? So they have limited space, 8 GB, 16 GB, 32 GB, something like this, right? So you want, whenever you write any code, it should consume less space, right? So the code that consumes less space, that is better. So if I want to give you a very vague idea, program runs in RAM, right? So whenever you run any program, first of all, it has to be loaded into the primary memory, that is the RAM. But I won't go into these architectural details at this point of time because these are a part of operating system. Okay. We'll do it in module D when we study about OS or operating systems, right? At the end. But yeah. So if I want to give you a very vague idea, what is a good code? A good code is a code that reduces time and space. Do you agree? I want to reduce my time and space usage. That is what a good code is. So all of us agree, yes, time and space are two very critical resources, and we should try to optimize time and space as much as possible in the code that we are writing. Okay, cool. ROM and hard disk, they are the same thing, right? मैं बोल रहा हूं कि भैया आपका कोड को कम टाइम में चलना चाहिए एंड योर कोड शुड कंज्यूम लेस स्पेस. आपका कोड को कम स्पेस ऑक्यूपाई करना चाहिए रैम का. ओके, so that this is a good code. That is how I determine. Okay, no blank lines are not included. Let us try to see what happens. Okay, we'll try to understand. Okay, so now everybody agrees with me that boss, correct, time and space. What is the response time? The time that it takes to give you the output, right? The time that your code actually takes to generate a response. Okay, so time and space are two very, very critical resources. Everybody agrees. And we have to try and optimize time and space whenever we try to write a code. But now the first question that you will try and ask me, hey Adarsh, how do I compare the time and space of multiple codes? Okay, so let's say if I tell you, boss, person A, okay, person A has written a piece of code and it is running in 10 seconds. Okay, you are getting the output in 10 seconds. And let's say person B has written a piece of code that is giving you the output in 50 seconds. Okay, so my question is, can you tell that person A's code is better than person B? Logically सोच के यही लग रहा है ना कि person A's code is better than person B. But I will tell you, we never compare the absolute runtime. We never compare the absolute runtime of algorithms. No, we never compare the absolute times. Why? Because see guys, try to understand. A might be running this code on a new computer, on a new processor, on an i7 processor. B might be running the code on a very old computer of a very, very slow processor, right? Similarly, let's say that, you know, the logic is to find the average of numbers, right? So A might be getting an input, ki boss, find the average of 10 numbers. And B might be getting an input, find the average of 1000 numbers. So definitely I am expecting now, if the input is 1000 numbers, it will take some more time to compute the average. Is it logical? Boss, if your input size is larger, ऐसा समझो कि the code that you are writing, if the load on that code is more, then definitely it will take more time. If the load on your code is less, if the input size is small, your code will take less time to run. And similarly, the environments, the platforms on which we run the code, they are different. Everyone is running the code on a different hardware. Okay. See, if you are running it on an i7 processor, which is very strong, definitely you will get the output fast, right? If you are running it on a very, very old computer, boss, your processor hi itna kharab ho gaya ki you will get the output in a slow amount of time. So definitely what I want you guys to understand is, because different people will be feeding different inputs, the load of your program will vary. And different people will be running the code in different environments or different hardware. Definitely, you cannot compare the absolute runtime of the codes. Does everyone agree? Does everyone agree? Can you compare the absolute runtimes? No. Why? First of all, the hardware will be different. Okay. And the second reason is the input that different people give, that might be different. So definitely comparing the absolute runtime is not a very wise thing to do. Okay, not a very wise thing to do. See, even if both A and B give identical inputs now, the environment on which they are running the code is different. ओके, एब्सोल्यूट रन टाइम मतलब ऐसे कंपेयर करना, 10 सेकेंड्स, 50 सेकेंड्स, 100 सेकेंड्स, वैसे टाइम देख के कंपेयर करना. ओके, even if they both give identical inputs ना, simulating the same environments are very difficult task, right? तुम एक ही कोड को दो बार रन करोगे ना on your same computer, you will get different run times because there are multiple processes happening in your computer, right? There are multiple background processes also running. Okay, so long story short, absolute run time should not be compared of any code. Okay, similarly, we never compare the absolute space occupied by a program. Why? Because maybe in Java, an integer can take 4 bytes. Okay. In C++, a character can take 1 byte. In Java, character can take 2 bytes. Okay. So different programming languages, different architectures, they can have different memory usages. So definitely comparing the absolute time and space is not an option for us. So you will come and ask me, hey Adarsh, if I cannot compare the absolute time and space, how do I judge which code is better? How do I judge? And that is why I tell you time and space complexity will come to the rescue here. Okay. So if I want to understand what is time complexity, if I want to understand what is time complexity in very simple terms, I will tell you, boss, I want to understand the time taken by the program. Okay. I will understand what is the time taken by the program to run as a function of input. मैं क्या बोलूंगा, boss? See, hardware is something which we cannot control, right? But input is something that we can definitely control. So what I will tell you, the time taken by a program to run as a function of input, that is what is time complexity. Okay. So what I will tell, represent the time taken by the program. What is this T? The time taken by the program as a function of my input size. This is what I will want to do. Okay. I will want to say, boss, my time varies according to input size. How does my time change with input? Please repeat. मैं बताता हूँ. See, what I want to do is I want to understand how does the time taken vary with the size of input. देखो boss, मैं ऐसा बोल रहा हूँ. Let's say there are two people. Okay, there are two algorithms, right? There are two algorithms. Okay. Now, if I feed an input of size 2, let's say if I feed an input of size 1, okay, then assume that this code runs in 1 unit. Okay. Similarly, for this code also, if you feed a size of 1, if you feed an input of size 1, you will get the output in 1 units. But let's say if I increase the size of input, if I increase the load of my program, let's say I give an input of n is equal to 1000. Okay. Then, or let's say for n equal to 1, ऐसा सोचो, okay, n equal to 1000, let's say you get the output in 1000 units of time. Okay. But when you feed an input of n equal to 1000, when you feed a large input to the second program, I will get the output in, let's say, 10 raised to 6. 10 raised to 6. Okay. So can you tell me which one is better? अभी अगर हम लोग एक बार एक रफ जजमेंट लेना चाहे, which program is better, first one or the second one? First one. Because if you see, when I give a very large input, see, at smaller inputs, both the program ran approximately in the same time. But when I feed a very large input, okay, when I increase the load of my program, when I increase the size of input, जैसे जैसे मैं input का size बढ़ाता हूँ, this program takes lesser amount of time to run as compared to this program. So this program has scaled well. This program has scaled well. कि boss, आपने जब input का size बढ़ाया, तो you got the output in a quicker time from A as compared to B. 10 to the power 6 is, let's say, इतना seconds लगा. ठीक है. तो मैं क्या बोलता हूँ, boss, what I have to do is, see guys, can I say for this, for algorithm A, can I say that the time taken by the program varies linearly with input? See, when n was 1, 1 unit was taken. When n was 1000, 1000 units of time was taken. So can I say that the time taken by algorithm 1 is varying linearly with the input size? जैसे जैसे मैं input का size को बढ़ाऊंगा, the time taken will scale in a linear fashion. Can I say this for program A? Yes, I can. देखो ना boss, 1 पे 1, 1000 पे 1000. So as the input size became 1000 times, the time taken also scaled by 1000 times. So it's a linear scaling between the input and output. But what is happening in program B? If you see in program B now, can I say that the time taken by the program to run is varying with n square? Ki boss, as I increase the size of my input, my time taken will increase in the fashion of n square. देखो ना, जब 1 था तो I was getting the output as 1. But when I increased n to 10 raised to 3, the time scaled in a quadratic fashion. Okay, quadratic fashion. See, 10 to the power 6 हो गया. Okay. So we are never comparing absolute time. What I want you guys to give me is the time taken by the program. I just have to express the time as a function of the input size. Ki boss, as I increase my input size, how does the time actually change? मेरे को सिर्फ ये relationship चाहिए. Okay. कि is time scaling in a linear fashion, or is it scaling in a quadratic fashion? Is it scaling in a cubic fashion? Something like this. ठीक है. जैसे जैसे मैं input का size बढ़ाता हूँ, how does my time actually vary with input size? I am not talking of absolute runtime. I am talking about the relationship between time and the size of input. That is what is time complexity analysis. How is the time varying as you increase the size of input? So jaise jaise, see, if I tell you something like this, if I tell you time is directly proportional to n cube, तो इसका मतलब क्या हुआ? As I increase my input, I forget the graph of n cube, but ऐसा ही कुछ होगा, ठीक है? So as I increase my input size ना, the time taken will increase in n cube fashion. तो जैसे जैसे आप इनपुट का साइज इंक्रीज करोगे, the time taken will scale in a cubic fashion. Okay. So if I ask you something like this, boss, there is one program in which the time is scaling in quadratic fashion, and there is another program in which the time is scaling in a linear fashion. Then what will be better? Can anybody tell me? N means it is linearly scaling with input. Okay. As you increase the size of input, the time will scale in a linear fashion. Okay. So for the second one, time is scaling up like this. Okay. And for the first one, time will scale in the way n square. So can I tell you, boss, for very, very large values of n, okay, अगर मैं अपने system पे बहुत ज़्यादा load दूँ, okay, then this program will take more time as compared to this program, right? So I am just interested in knowing how is my time varying as a function of the size of input. कि जैसे जैसे मैं input के size पे increase करूंगा, as I increase my input size, how does the time taken actually vary with input size? Okay. I just want to know this relationship. Cool. Now, okay. Now let's come to an example, right? Let us see. Okay. So let me just take a poll. Let's try to करके देखते हैं. मैं first time try कर रहा हूँ. I'll just take a poll to check how many people have understood versus how many people have not understood. Okay. So just activate the poll. Okay. See, environment का तो मैंने eliminate ही कर दिया ना. I am just interested in what is the time taken by the program to run. Okay. As a function of input. Okay. कि जैसे जैसे मैं input के size को increase करूंगा ना, how is my time taken? How is the time varying with the input size? I just want to get that relationship. Okay. Can you guys just do a quick poll of how many of you are clear with the concept? I just want to get an idea of how many are clear till now. I'll just appreciate this. This actually gives me a better picture of what is going on in the class, right? Okay. Where can we vote? I've shared the link in the chat. Just go to this link and just maybe, give in your responses. एक बार साइट पे जाके देख लो. I have shared the link with you all, right? We have 577 people, so I am expecting around 250-300 लोग तो करेंगे, है ना? Okay. So I think majority of the people are clear, right? And the 30% people who are not clear, right? When we do with examples, right? More of you will become clear. right? Can you please share the link? Yes, for sure. Why not? Okay. Okay. So yeah, I think we haven't discussed anything practical till now. But yeah, if you are clear with the concept till now, you will be easily able to follow it, right? Okay, cool. Okay, guys, I got a decent understanding of what's going on. I will take examples for sure. Okay, I have just stopped it. फिर से करेंगे बाद में, ठीक है? Yes. So basically, long story short, what I have to conclude at this point of time is I want to express the time as a function of the input size. Okay. As I am increasing the size of my input, how is the time varying with the input size? Okay. मेरे को सिर्फ ऐसा लिखना है कि my time varies in n fashion, or my time varies in n square, or time varies in n cube, something like this, right? So what is this statement telling you? As you increase the size of n, as you increase the value of n, as you increase the size of the input, the time taken will increase in an n square fashion. Okay? बस अभी हम लोग को यही समझना है. Okay, how will we come to this expression? Let us see via examples. Okay. So we will basically try to take certain pseudo code, right? And we'll try to do it. Okay. See guys, when I say कि तुम मेरे को बताओ how is the time varying with input size, so do you agree I have eliminated everything of the hardware? I am just interested कि as the input is increasing in size, how is your time changing in a linear fashion, in a quadratic fashion, or what, right? This is the general thing. Okay. So what is a pseudocode? Pseudocode is a code which is not syntactically correct. It might not be syntactically correct, but you will understand what is the code doing. Normal English code, right? Kind of. Okay. So let us take an example, right? Let us take an example. Okay. So let's say I do something like this. I take an integer n input from the user. Then I print SOP, hello. Okay. Then I'm just writing a piece of code. Acha guys. So what is this code doing? My n is input from the user, right? This is the user input that you will be expecting from the user, or this is the input parameter which we have to evaluate. Can you tell me what is this code doing? First of all, it will print hello, then it will print yo n times, and then it will print done. So can anybody tell me what is the major time contributor of this code? What will be the major time contributor of this code? Guys, try to understand what will happen. If I give the value of n as 10, agar main n ki value 10 deta hu, what will happen? I will print hello, then I will enter inside this loop. How many times will this loop run? This loop will run for 10 times. I will print yo for 10 times, and then I will print done. Now, let's say I increase the value of n to 10,000. So what will happen? First of all, I print hello, then I will enter inside the loop. And think of it like inside this loop, you will get trapped. Ye loop pura n times chalega, right? So you will run this loop for 10,000 times and you will print yo for 10,000 times. Then you come outside the loop and you print done. So do you guys all agree that the loop is the major time taking portion of your program? Where will you spend most time? You will spend your most of the time in the loop. तुम loop करते जाओगे and you will be printing. So the major time contributing factor of this program or of this code is this loop. Okay, this SOP yo that I am printing, that is the major time contributing factor. Okay, so can anybody tell me how does the time taken by this code actually scale with input? See, if n was 10, the loop ran for 10 times. If n was 10,000, the loop ran for 10,000 times. Yes, we have to focus on the major contributor only. So can I tell you one thing? The time taken by the program, the time taken by this code will vary in a linear fashion with n. As soon as you increase the value of n, the for loop will run for more number of times and the time taken by my program will increase in a linear fashion. Is it making sense to everyone? This for loop will run for n times, right? And this is the major time contributor. So as you increase the value of n, the time taken by the program to run will scale in a linear fashion. So time is directly proportional to n, or it is varying in a linear fashion with the size of the input. Okay. Now, similarly, if I give you the same code, okay, if I give you the same code, if I give you the code in 10, you have taken as input from the user, right? And let's say I take a variable a equal to 0, and then I run a loop. Okay. Again, what is the major time contributing factor of this code? This for loop, right? Because this will be running for n times. So can I tell you guys, if you are able to compute how many times this operation is performed? See now guys, the number of times this operation a is equal to a plus 1 will be performed. Kitna bar perform hoga ye operation? The number of times the loop runs, that many times you will be performing this operation. So if I am able to determine how many times this operation runs, I will be able to determine the time taken by the program to run. Karthik, what I am trying to say is, see, in this code, what is the major time contributing factor? The major time contributing factor is this for loop, right? This loop will run for n times, and every time the loop runs, this operation a is equal to a plus 1 will be performed. Okay. So if you count how many times this operation will be performed, that will give you an idea of how is the time varying with the input size. Okay. So again, can I tell you, this loop will run for n times. Why? First of all, I will take a value of 0, this loop will run. Then I will take a value of 1, the loop will run. Likewise, I will take values till n minus 1 and the loop will run. So how many times has the loop run? From 0 till n minus 1. That is n different times the loop has run. N different times. Okay. So can I say the time taken by this code will be varying in a linear fashion with n? Do you all agree? Yes. See guys, I will tell you shortcuts also later via which you will be able to understand and you will be quickly able to tell me. But here let us try to focus on the fundamentals, right? So if you are able to know how many times this operation will run, you can tell me what is the time taken by this code to run. Great. Now, so this is linear variance, right? This is the linear variation, right? Okay. Now I'll give you another code. How can we say it runs as linear? Because see now, as you increase the value of n, more number of times the for loop will run, right? If n is 100, this runs for 100 times. If n is 200, this runs for 200 times. And this operation will be performed 200 times. So these operation, the number of times this operation is performed, that is increasing in a linear fashion only. That is why. Okay. Now, I'll give you another code, right? You will help me. This is input, right? So whenever, yes, a single for loop means linear, right? We'll see. So n is basically an input. Okay. I have made a variable int a is equal to 0. You will help me with this one. Okay. I want to find what is the major time contributing factor of this code. Can I say, boss, these nested for loops are the major time contributing factor of this code? And now, see now, these are two simple statements, and then this nested for loop will run. So this nested for loop is a major time contributing factor of my program. And if I want to understand how is the time varying with input, can I tell you, boss, what is happening? When this loop runs, what is the operation that you are doing? Every time the loop runs, you are doing a is equal to a plus 1. So can I tell you the number of times this operation is performed? That will give me an idea of the time taken. Do you all agree? The number of times this operation is performed, that will give me an idea of what is the time taken by the code to run. How do I evaluate? Let us see. How many times this statement actually runs? Let us try to understand. So what will happen? First of all, I will take a value of 1. Yes. And for I equal to 1, how many times will this inner loop run? Can anybody tell me? See guys, first of all, I will take a value of 1. How many times will this inner loop run? N times, right? J will start from 1 and go all the way till n. So this operation will be performed n times. Then what will happen? Then the value of I will become 2. Okay. And for I equal to 2, again this inner loop will run for n times. Do you all agree? Right? So this operation is again performed for n times. Similarly, for I equal to 3, this operation is performed for n times. Likewise, what happens? Till I equal to n, again this operation is performed for n times. So how many times has this operation been performed? Add all these up. N plus n plus n plus n. How many times I'm adding n? For n different values of I, you are adding n. So you are adding n times. So what is it? It is nothing but n into n. That is n square. Is this making sense what I'm trying to say? Dekho boss, you just have to follow the flow. First of all, I will take a value of 1. And when the value of I is 1, this inner loop will run for n times. Write it here. Okay. Now, excuse me, error is any? No, it depends on your logic. It depends on your logic, right? Then the value of I will become 2. And for I equal to 2, what will happen? Again, this inner loop will start running. So j will take a value of 1, 2, 3, 4 till n. So the inner loop run for n times. Then I ka value will become 3. And again, the inner loop will run for n times. And aise karte karte, for every value of I till n, the inner loop will run for n times. That is, this operation is performed n times, right? So how many times is this operation performed? This operation is performed for n plus n plus n plus n plus n. How many times are you adding up n? For n different times you are adding n. So it is n square. Okay. So I can say that the time taken by the program is varying in n square in a quadratic fashion. Because if the value of n is 5, then this operation will be performed for 25 times. But if the value of n is 6, this operation will be performed for 36 times. This is n. This is n. Okay. J equal to 1, j less than equal to n. Okay. Is this making sense, guys? How do I calculate the number of times the inner this thing runs? Yes, correct. If you use 3 nested loops, it will be n cube, right? So the shortcut is if you have 2 nested loops, now you can simply multiply. This outer loop runs for n times, the inner loop runs for n times. N into n is n square. That is a, kind of a shortcut. Okay. J equal to 1, j less than equal to n, j plus plus. Okay. Yes, correct. Like star pattern. Okay. So is everyone clear with this fundamental analysis of how many times this operation has run? That is n square number of times. Okay. So the time taken will vary with n square. Okay. Let's move further. See, what I am trying to do is I want to understand what is the major time contributing factor. Okay. Remove a is equal to a plus 1. Write SOP hello. Okay. So this printing of hello will take the most amount of time, right? Because this nested for loop will keep on running and printing hello. So the number of times this hello will be printed, that will give me an idea of how many operations are getting performed. Okay. So calculate kar lo kitne baar ye hello print hoga, right? So first of all, the value of I will be 1. And for I equal to 1, how many times hello will be printed? N times. Then the value of I will become 2. This inner loop will again run for n times and print hello. So how many total times hello is printed? Just add this. N plus n plus n plus n plus n plus n. How many times you are adding up n? N different times you are adding up n. So that is nothing but n square. Okay. Let's move further. Okay. Sab karenge, guys, sab karenge. Just hold on your questions for some time, right? We'll cover everything, right? We will cover everything. Okay. Now, can anybody help me with this? You are doing some work here. I don't care what you are doing. Can anybody tell me the time taken? How will the time vary? M into N. Okay. Kaise bola? The outer, these two loops are nested. So the outer loop runs for M times and the inner loop runs for N times. So what is the total time taken? M into N. So the time will vary with M into N. Okay. But if let's say you want to calculate exactly, so how will you calculate? I just have to see how many times this operation is performed. How many times this operation is performed. So what I will do, evaluate karte, right? First of all, I will take a value of 0. And when I takes a value of 0, how many times is the inner for loop run? If you print hello world n times without a loop, that is also n only, na? So when the value of I is 0, do you agree that the inner for loop will run for n times? Yes. So n times run hoga. Okay. Then the value of I will become 1. And again, you will see that the inner for loop run for n times. Okay. Likewise, the I will take values till where? Can anybody help me? Till where I will take value? Not m minus 1. Till m minus 1, I will take a value. So I equal to m minus 1, again the inner loop will run for n times. So now if I want to calculate how many times this operation has been run, can I add up all these times? Let us add n plus n plus n plus n plus n. How many times are we adding n? We are adding n m different times. Why? See now, I equal to 0 ke liye you are adding n. Then I equal to 1 ke liye you are adding n. So you are adding n m different times from 0 till m minus 1. These are m different values. Guys, try to understand. If I tell you I equal to 0, I equal to 1, I equal to 2, I equal to 3. So these are 4 values, right? For 4 different values, you are adding up a number, right? So you are adding n m different times. Okay. Guys, you are getting confused. How many times this loop is running? 9. J run n minus 1 times, not n times. You are wrong here when you say. Okay. See, we don't take values of n. Okay, guys. First of all, let us clear this fundamental confusion. How many times will this loop run? Do you say that this loop will run for 4 times or 5 times? Boss, 5 times run hoga. यहाँ पे एक काम करना, go to your compiler, write a loop and write SOP hello. See how many times hello is printed, right? First of all, I will take a value of 0, you will print hello. I will take value 1, you will print hello. I will take value 2, 3, 4. For 5 different values of I, you will be printing hello. Okay. Yes, 0 to 4, I is taking values. But because I have started at 0, these are basically 5 different values. So can I tell you guys, the number of times this operation is running is n plus n plus n plus n plus n. And how many times I am adding n? M different times. M different times. So you are adding n m different times. So it is nothing but n into m. Do you all agree? Yes. And because you have 2 nested loops now, you can even multiply. M times here run kar raha hai and this is running n times. So m into n is mn. Okay. Yes, Bibhuti, you can neglect the other statements which are not inside the loop. Loops are the major time contributing factor. Okay. Cool. So I hope everyone is clear till here. Okay. Dekho guys, the most important part is this understanding. If you understand how to, calculate the number of times this operation is running, then you can easily tell me how the time actually varies with input size. Okay. If there is another nested loop, then what will happen? If you have 3 nested loops, then it is n cube. Okay. Okay. Let us. How we got m into n? Okay. How did we get? See guys, pehle I ki value 0 hi, and for I equal to 0, how many times did the inner loop run? The inner loop ran for n times. Then the value of I became 1. The inner loop again ran for n times. Okay. Then the value of I will become 2 and the inner loop will run for n times. Okay. Now, ऐसे करते करते, the last value that I will take is m minus 1 and the inner loop will run for n times. So how many times has this operation run in total? N plus n plus n plus n plus n. ऐसे करते करते. So how many times are you adding n? M different times. For I equal to 0, 1, 2 till m minus 1. So for m different values of I, you are adding n. Okay. So if I add 2 3 times, then what is the result? 2 into 3. So similarly, if you add n m times, the result is n into m. That is how I am getting n m. Is it making sense? How many of you are understanding what is going on? Yes? Okay, cool. Let us move forward. We'll try to understand with examples only, right? Acha. Now, similarly, let me talk little bit about space. Okay. So let me take a code and here we'll run something interesting. Int n. This is the input, right? You take m-1, but why not n-1? Divya, try to understand what have I done. मैं बोल रहा हूं for I equal to 0. How many times the inner loop run? J will take values from 0 till n-1, right? That means the loop is running for n times, na? Boss, J is taking a value 0, then 1, then 2, then 3, then 4 till n-1. So how many times the loop has run? For n different times, na? That's it. Okay. Now let us talk about a little bit about space, right? A little bit about space. Okay. Yes, result is m into n. Okay. Now let's look at this. What is the space? How will the space vary with input? नहीं करेंगे Ramanuj. We have lots of things to do. Don't worry. Okay. How does the space vary with input? Just giving a small example, right? So what are the space takers in the program? The variables will occupy space, right? But guys, try to understand. Let's say the value of n is 100. Okay. How much space will you reserve in memory? You will need one space for an integer n, another block for integer a, another block for integer I. Okay, these three blocks you will reserve. But even if n is 10,000, you will be reserving the same three blocks of same size, right? As long as n is fitting inside an integer, the space taken will not change. Do you agree? Boss, n equal to 100 store karo, या n equal to 10,000 store karo. You can store it in the same 4 bytes of memory. Okay. So what I want to say is when you just have basic variables now, I will say that the space taken by the program is independent of n. Even if you increase the value of n, if you increase the value of n, the space taken by the program will not change much. It will not change, right? Because whether n is 10, 15, 20, 100, 1000, you still have to reserve 4 bytes only for n. Okay. So the general rule of thumb goes like this. When we have only basic variables, right? Basic primitive variables don't contribute to space. They don't contribute to space, right? What contributes to space? Arrays. Okay. So let's say if I make an array of size n, right? Then the space is varying directly with n. Do you agree? If my n is 100, then I will reserve a space for storing 100 integers. If n is 10,000, then I will reserve a space sufficient for storing 10,000 integers. So the basic primitive variables, that we have, they don't consume space. They don't consume any, significant amount of space. Whenever we talk of space, what will be taking up space? The data structures will be taking up space, like arrays, okay, stacks, queues that we will later talk about, function contexts, right? Correct. So does everyone agree why the space of this code is independent of input? Bhai, n ka value agar 10 hoga na, still you will have to reserve 4 bytes to store n. And even if n goes to 10,000 or 1 lakh, you will still have to reserve 4 bytes only to store n. So that is why the space taken by the program is independent of the size of input. But yes, if you are making an array of size n, then the space taken by the program will vary linearly with n. Linear fashion mein vary karega. Okay? Cool. Now, what I want you guys to understand is, what if there are 5 different data types? String, double, long, int, float. Then you will only look at strings, right? Because they are the non-primitive data types. Okay? See, all the primitive data types, they won't be contributing to your space complexity. The primitive data types won't contribute to your space complexity. See now, in this question, you are using 3 different variables now. Even if you increase the size of input, 1,000, 10,000, 1 lakh, 10 lakh, right? Still, you will reserve 4 into 3, that is 12 bytes of memory in the RAM to store your variables. Okay. Yes. String ke liye, yes. String ke liye you will have to see what is the size of the string. Okay. What if one person is using int and another double? No. For both the spaces will be identical, right? We don't differentiate on space on the basis of primitive variables. Okay. Yes, space complexity. See, we'll understand it via more examples. But for now, the major contributor of space will be arrays, queues, stacks, and all the other data structures, strings. These will be the major contributors of space. Okay. Now, whenever I say something to you like this, that boss, yeah. So if the time taken is directly proportional to n, okay. Now we generally have certain notations, right? We do some asymptotic analysis. मैं बताऊंगा इसका meaning क्या होता है, right? We generally have certain notations, right? We don't write like this, कि the time is directly proportional to n. We have different notations, right? So let us talk about the 3 notations that we will be studying, okay? One is big O notation, okay? So when I write something like big O of n, what do I mean to say? This expression will tell me how does the time or space vary. This will tell me how does the time or space vary. Okay, how does the time or space vary? So if I tell you that the time complexity is big O of n, that means the time taken by the program varies in a linear fashion. It varies linearly with n. Okay, so within brackets we write what is the relationship in which the time is varying with the size of input. And what does this big O mean? This big O actually stands for worst case analysis, worst case. Okay. So what I am telling you, when I say that something's time complexity is big O of n, so मैं बोल रहा हूँ, boss, in the worst case, you can expect the program to run in linear time. कि boss कैसा भी input दे दो, you give whatever input to your program. In the worst case, it will run in linear time. So this linear time is like an upper bound. Okay. So think of it like the linear time is a upper bound है. Worst case है ये, इससे ज़्यादा time नहीं लेगा. Okay. See, what is the meaning of worst case? We'll understand with an example. But what I want you guys to understand is when I say that something is big O of n, that means, see, to your program, right, there can be different kinds of inputs, right? Let's say there are 3 types of inputs, A, B, and C. Okay. Now, for input A, मैं क्या बोल रहा हूं? Give any input that you want. Okay. Give any input that you want to your program. In the worst case, see, some input might be good, some input might be bad. So even if you give a very bad input, you can expect your runtime to be linear. So in the worst case, कुछ भी दे दो input, जो फेंकना है फेंको, जैसा input देना है दो. Give whatever load that you want to give to your program. In the worst case, you can expect the runtime to be linear. You will get the output in linear amount of time. This is like an upper bound, right? That is, my program will not take more than n time to run. This is an upper bound. Worst case, right? Worst case. Okay. Now, the second notation that we talk about, I will take an example also to make this more clear. The second notation that we talk about is omega. Okay. And if I say something is omega of n, what does it mean? Again, this is showing you the relationship. And omega notation is for best case. Ki boss, in the best case, okay, in the best case, you can expect your code to run in linear time, right? This is the best case. Ki boss, you cannot get a runtime faster than this. Okay. Yeah. See, big O of n means give whatever input, you can expect your code to run in linear time, right? This is the upper bound. This is the worst case. It will not take more than this time. And best case is, in the best case, my code will run in n time. It can never run faster than n. It cannot run faster than linear. This is your best case, omega notation. Okay. Big O is telling you the worst case, right? Worst case. Okay. You can expect always that this will run faster than this or this. It is the worst case analysis. And omega is best case. Okay. And the third notation that we talk about is theta. Theta notation. Theta notation tells you the average case runtime. Let's say you are giving different inputs. How much runtime you can expect on an average case? Boss, if I run the program on a random input, right? On an average, you can expect the runtime to be whatever you write here, that is linear. Okay. So big O stands for worst case, omega stands for best case, okay, and theta stands for average case. Okay. Now let me take an example to help you guys understand this in more detail. Okay. So let us say that you have an array of size n. N is the input size, right? We are always talking about the time and space complexity with respect to input size, right? One second, guys, 1 second. Okay, yeah. So now let's say you have an array of size n. Okay, you have an array of size n. Okay, and I want to search for a target inside this array. मैं क्या बोल रहा हूँ, boss? You have an array of integers. Okay, you have an array of integers of size n. Okay, of size n, you have an array of integers, and I want to search for an element, and I want to give you the index of that element inside this array. Okay. So what I will do, what I am talking is a linear search. This is a linear search, right? So what I will do, I will start searching in the array. Okay, I will start searching in the array. Okay. So let's say you have an array of size n, and you can get any input, right? I don't know what kind of input you have, but the size of the input is n. Okay. So first of all, you will come and inspect this place. Nahi mila, so you will go further. Nahi mila, you will move further. If you don't find here, you move further. Okay. So what is your worst case? What is your worst case? Your worst case will be you basically scan the entire array. You iterate through the entire array and you don't find the target element. That is your worst case input. Batao bhai, if you iterate, see, you have to iterate through the entire array and then you have to conclude that, boss, the target is not present in the array. So that is my worst case कि मेरे को array में target मिला ही नहीं. Okay. And can you tell me what is the time taken in the worst case? Can I say in the worst case it is big O of n? Because if you have an input, let's say, okay, let's say that my target is 11. My target is 11. For this input, my target is 11. Then what will happen? You will have to iterate through the entire array before you conclude that, boss, 11 is not present in the array. So for this is like a worst case input, right? This is like a worst case input. In the worst case, you will have to iterate through the entire array, okay, before you can conclude that, boss, my target is not present in the array. So can I say, yes, worst case is sabse bekar input, the worst input, right? For which you will have to do the most amount of work. So can I say that the worst case of linear search is big O of n when the target is not present in the array? Last में भी होगा, that can also be there, but yes. Do you all agree it is big O of n? Worst case runtime of linear search, because you have to go and inspect each and every of the n different locations in the array. Okay, so this is the worst case runtime of linear search. But if I now ask you, what is the best case runtime of linear search? Okay, so what will be the best case? What is the most ideal case for you? That, boss, you inspect the first element and you find the target. सबसे ideal case यही है ना, that you start and you just get the target element in the first place itself. Now tell me, guys, if you find the target in the first place itself, do you care whether the size of the array is 100 or the size of the array is 1000 or the size of the array is 10,000? No, no. You just inspect the first location, you get the target, you break out. So can I say the best case of linear search will be constant time? Constant. It is independent of input. I don't care about the input size. Okay. The best case will not be dependent on the size of the array because you will just inspect the first position and you get the target. Okay. So if something is independent of input size, now we generally write 1. We generally write 1 to tell that the time taken is constant. It is independent of the size of input. So this is my best case. Do you all agree? Do you all agree the best case? देखो ये समझना है कि in the best case you will find the target in the first index itself. At index number 0 only you will find the target. Okay, so in the best case is not dependent on the size of the array. Okay, let's say you have an array of size 100. You have an array of size 100. What will you do? You inspect the first location, you find the target, you give me the answer. Okay, if your array is of size 10,000, then also you will inspect the first index and you will return the answer. That is the best case, right? So for the best case, you don't depend on the size of the array. Whether my array size is 100, 1,000, 10,000, 1 lakh, right? You will get the answer by just checking the index number 0. So can I say my best case runtime is independent of the size of input? And in order to tell that it is independent of input size, now we write 1. What does 1 specify? It is constant. It is constant, right? Okay. Okay. If n is present at the last, definitely it's not your best case. That's the worst case, right? And can you guys think what will be the average case? सोच सकते हो क्या? What will be the average case? I'll let you guys think for the average case a little bit. But roughly, if you have a little bit of intuition, right? On the average, I can assume I will find the element in the middle. Okay. And if you find the element in the middle, how many search operations you will have to do? Approximately n by 2. So I will say that average case is theta of n by 2. Yes. I will leave the in-depth analysis for you all, right? Try to think of the in-depth analysis. But does it sound intuitive? That boss average way you can expect that yes, you will find the target in the middle. Okay. So you will have to do n by 2 comparisons. That is n by 2 inspections. So it is theta of n by 2. That is the average case of searching. Okay. Is it making sense, guys? How many of you are clear with this? Okay. And one very important thing, right? This big O, big omega, omega or theta, all these notations that we have talked about now, these are asymptotic notations. Asymptotic notations. Why n by 2? I will tell you. कल बताता हूँ ये, ठीक है? आराम से कल बताऊंगा, आज थोड़ा समझ लो, then we'll do, right? I will repeat the average case. See, in the average case, you can expect to find the element in the middle. Okay. So if you have the element in the middle and the size of the array is n, how many operations you have to do? You will search here, 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 and you will find it here. So you will have to do n by 2 comparisons. Okay. So that is theta of n by 2. Okay. Now, no, it is dependent on n, right? It will be dependent. Let's say if my array is of size 100, then you will have to search for 50 places. If your array is of size 10,000, you will have to search for 5,000 places. Enough. Okay. Now why 1 in omega? Because the best case is independent of the size of the array. The best case is when you find your target in the 0th index itself. So whenever something is independent of n, now we write 1. Okay. Now what I'm telling you, this big O notation, the omega notation and the theta notation, these are asymptotic notations. So whenever I write something like big O of n square, something like this, right? What I want you guys to understand is these are asymptotic notations. That is, we talk about these notations at very large values of n. Okay. When the load or the input is very large, that is where we talk about the just give me 1 second. 3, if you find it in 3rd or 4th index. See, I am not interested in specific cases, right? You are now talking of specific cases. What if I find it in 3rd index? What if I find it in 4th index? No, I am talking of the generic cases. What is the worst case? What is the best case? And what is the average case, right? Now, what I'm telling you, these are asymptotic notations. That is, if I ask you, boss, one algorithm is big O of n. The worst case is big O of n. Index 0 and index 1. That is not a case. Right? We will take questions, guys. Don't worry. Okay. Now, if I say that one algorithm is big O of n and one algorithm is big O of n square, can you tell me which one is better? The first one is better or the second one? See, guys, whenever I talk of asymptotic notations, The first thing that you need to understand is I am talking of very, very large values of n. Okay. We talk about these analysis or time and space complexity analysis for large values of input, for very large values of input. So when n is very large, definitely n square, if you look at the graph now, if you look at the graph, n square will grow at a much, much faster pace as compared to n for large values of n. So definitely this will be more time consuming as compared to this. Do you agree? Yes. Okay. But see guys, ऐसा हो सकता है for small values of n, this might be comparable with this. Okay. I cannot always say that this is worse than this. Okay. That is why we need to be very specific. Yes, big O of n is better than big O of n square, but at large values of n. At small values of n, n and n square are comparable. For n equal to 1, n equal to 2, they are comparable. So whenever we talk of the big O notation, big O, omega notation, theta notation, right? We are talking of the large values of inputs, large values of input. And at very large values of n, definitely n square will grow at a much, much faster pace as compared to n. So big O of n square takes more time as compared to big O of n. Okay? Is it making sense? Okay. Long story short, मैं बोलना चाह रहा हूं कि whenever I talk of any of these notations, right, big O, theta, omega, I am talking about large values of n. Okay, we do asymptotic analysis. We are not interested in small values of n, because for small values of n, n square, n cube, they are approximately the same, right? The real difference starts coming when you look at large values of n. Okay, so we are more interested in the larger values of n. Okay. Mukul, I don't think this will be possible for me to repeat everything in Hindi. Otherwise, I'll become very slow, right? So I'll request that try to follow what I'm trying to say in English, because it will be very difficult for me to, repeat again in Hindi. Okay. So, acha guys, if I give you an option, if I give you an option, big O, omega or theta, what will you report your answer in? If I give you, boss, you have three options: big O, omega, or theta. What do you think will be a more logical assumption? What should you give your answer in? See, we use most commonly the big O notation. Why? Now let me give you a very practical example. Let's say you have made a product and you sell it in the market. Okay. And you tell your customer that, boss, in the worst case, you will get your output in 10 seconds. Okay. So the customer uses your product, and if he gets the output in 8 seconds, do you think the customer will come and complain to you? Ki, hey, Adarsh, you told me that the worst case is 10 seconds, but I got the answer in 8 seconds. No, the customer is prepared for the worst case. Ki, aapne bola hai worst case 10 seconds hai, so I am prepared for that. But if you tell that, boss, if I report the best case, boss, the best case of the product is 5 seconds. Okay. So the customer can give an input which consumes 10 seconds. Then the customer will come and complain to you. Ki, boss, you were telling that your runtime is 5 seconds, but I gave an input for which the runtime was 10 seconds. That is a problem. Okay. So definitely, whenever I am reporting the runtime of any code, right, most commonly we use the big O notations. We are interested in the worst case time complexity analysis. Okay. Then what is the use of other asymptotic notations? They are developed for your understanding, right? But most commonly you use the big O notation for reporting everything. And guys, the big O notation has become so common in our day-to-day usage that you might see something like this also written. The best case runtime is big O of n. ऐसा भी दिखेगा बहुत जगह. The best case runtime is big O of n. We have become so familiar with the big O that we also sometimes use it for the best case or the average case. But technically this is wrong, right? Best case should be written like this. But if you find something like this written, don't worry. This is also fine. Okay? Okay. Now let us try to solve some problems and you will tell me what is the output. Okay. Big O of n, mostly because generally we use single loops, right? So small O यार नहीं पता, big O पे ही सीखे हैं, है ना? Can anybody tell me the time complexity of this code, the worst case time complexity? Anybody? M plus n, M plus n. Okay. So how do I understand this? How many times will this loop run? This loop will run for m times. Okay. And this loop will run for n times. Okay. So if you write here SOP hello, so this will print hello m times. And if you write SOP hello here, this will print hello for n times. So how many total number of operations have been performed? M operations are performed because of this loop, and n operations are performed because of this loop. And these are not nested, right? So the total number of operations is m plus n. Do you all agree? So I will tell you that the worst case runtime of this code is big O of m plus n. Okay, big O of m plus n. Is everyone clear with this? Yes, makes sense? Okay. Up class interesting hoga, right? Now we'll look at analysis. Okay. For nested loops, we generally multiply, right? We will see. But these are not nested, right? So this, let's say this runs for 10 times and this runs for 20 times. So how many total operations you are performing? 10 times this will run, 20 times this will run. So 10 plus 20, which is 30. So that is why I'm telling the m plus n. That is big O of m plus n. Okay. Now, let's come here. I'll give you pseudocode, right? I goes from 0 till n. What if two statements inside? I don't care about the number of statements, right? The major time consumer is the loop, right? You execute 5 statements or 10 statements. We don't care about that. I am more worried about the number of operations, right? Okay, guys, can you help me with the time complexity of this code? So guys, first of all, I need to compute the number of operations that are getting performed here. How many operations are performed? See, for nested loops, you can take this shortcut, right? N times this loop will run, n times this loop will run, right? I am pretty sure most of you should be clear with how to compute that this is n square, right? If for I equal to 0, the inner loop will run for n times. I equal to 1, this loop will run for n times. So if you compute, you will see that the number of operations because of this nested loop is n square. And then this loop will run for n times. So the total number of operations is n square plus n. So can I say the runtime is big O of n square plus n? Does everyone agree? Now, here comes one other interesting part, right? Now, what did I tell you guys? If whenever I am talking about these asymptotic notations, right? Big O, omega or theta, we are talking about very, very large values of n. So we have a couple of rules that we follow in these notations, right? The first thing is we drop the non-dominating terms. The first rule is you drop the non-dominating terms. What do I mean by this? See guys, at very, very large values of n, look at the graph. N is like this and n square grows like this. Okay. So at very, very large values of n, can I say that n square is much, much greater than n? Take very, very large values of n. You will see that n square is much, much greater than n. So I can neglect this n. I can neglect this n. So I will drop the non-dominating term. With respect to this n square, this n is non-dominating. So I can drop this non-dominating term. Okay. See, non-dominating term matlab if n ka value is 10 raised to 5, right? Then n square is 10 raised to 10. So 10 raised to 10 is much, much greater than 10 raised to 5. So this term is like a and, right? It is cheaty hai. Ye hati hai to ye cheaty hai, right? This is a very large number and this is a very, very small number as compared. So definitely n square is much, much larger than n. So you can just drop this term. Okay. And the second rule comes is I can also drop the constants. I can drop the constants. Okay. So big O of n square plus n, you can approximate it to be big O of n square. Because for very, very large values of n, n square is much, much greater than n. So you can drop this non-dominating term. So I will say this is big O of n square if I want to generalize or basically give you an answer. Is this making sense, guys? So always drop the non-dominating terms, keep the most dominating term, and also remove any constants that you have. Okay. Now let's take another example. Now it's all problem solving, right? It will now become interesting. Okay. Let me think of it. Okay. Acha guys, can you help me? If I want to give the answer for this, O of 3 by 2n, O of 3 by 2n, what do I give the answer as? What did I tell you? Constants get dropped at very, very large values of n. See, I am more interested in the relationship, not in the constants. Drop the constant. Big O of n. This is big O of n. Okay. Can you help me with this? What do I approximate it to? I drop all the non-dominating terms, right? Drop this in front of n cube. Now this 3n square is also non-dominating. Remove. So you are left with big O of n cube. Okay. So this is how we try to do approximations in case of, this asymptotic analysis. Okay. Cool. Now let's find this for can you help me? Can you help me? We'll take more examples. Can you help me? What is the time complexity for this? And first of all, the time complexity will not be dependent on I, right? Because my input is n. So you will have to give me the answer in terms of n only, right? See, if you follow the rule of thumb that I gave you, nested loops hai, so you can say n square. You can say n square, right? But see, this is not always the case. I will take a couple of examples where you will see that nested loops also don't give you n square. Okay. But if I want to go with my fundamental analysis kya karna hai? How many times this operation is getting performed, right? So let us calculate that and we will understand, right? So what happens? First of all, I will take a value of 0. Okay. Do you guys agree that the inner loop is running for I times? Kya tum log ye mante ho? The number of times that the inner loop runs is dependent on I. The inner loop is running for I times. Dekh lo bhai. 0 less than I, right? So the inner loop is running for I times. So when the value of I is 0, how many times will the inner loop run? 0 times. Can I say this? The inner loop runs for I times, so 0 times. Then the value of I will become 1 and the inner loop will run for 1 times. Okay. Then the value of I will become 2 and the inner loop will run for 2 times. ऐसे करते करते the value of I will become n minus 1 and the inner loop will run for n minus 1 times. So if I want to calculate the total number of operations, what is it? 0 plus 1 plus 2 plus 3 up till n minus 1. So I just have to compute this summation. Okay. And what is this, guys? This is the sum of the first n minus 1 natural numbers. Do you agree? This is the summation of the first n minus 1 natural numbers. So what is the formula for the sum of the first n natural numbers? This is the formula for the sum of the first n natural numbers, right? So what will be the sum of the first n minus 1 natural numbers? Just substitute n minus 1 for n. Okay. So it comes out to be n into n minus 1 by 2. Do you all understand this part? मैं क्या बोल रहा हूँ, guys? What I am doing, see, I have calculated that this is the number of operations that I've actually run. 1 plus 2 plus 3 plus 4 up till n minus 1. Now I know that in maths, we have a formula that the sum of the first n natural numbers is nothing but n into n plus 1 by 2. This is the sum of the first n natural numbers. But what do I need to find? I want to find the sum of the first n minus 1 natural numbers. So instead of n, I will write n minus 1. See, n minus 1. Instead of n, substitute n minus 1. So you got your answer. See, the number of operations in this program is n into n minus 1 by 2. So if I want to give you the time complexity, it is big O of n into n minus 1 by 2. Okay. And if you want to approximate it, can you tell me what is the approximation? Boss, n into n minus 1 by 2 hai. That is, it is n square by 2 minus n by 2. So you can approximate it to big O of n square. Big O of n square. Okay. See, where is the application of this? In evaluating the runtime of the code, right? अगर मान लो कि तुम एक code लिखते हो which is running in, which has big O of n square time complexity, and I write a code which runs in big O of n time complexity, then my code is better than yours. Can't understand the last 5 minutes. Okay. So what I did was I wanted to compute the time complexity of this code. Okay. And let me just make it once again. See, I want to find the time complexity. How can we use it? When you devise your algorithm, now in questions it will be written, try to make an algorithm of n square, log n, something like that, right? And depending on the constraints of the question, you have to develop an algorithm of that sense, right? But what I was saying is, let us try to understand this. See, my task is to evaluate the time complexity of this code, right? So what is the major time contributing factor? See, one way can be you have two nested loops, so just blindly tick n square, right? In this case, this turns out to be correct. But if I want to go via the fundamental analysis, what do we do? See, guys, how many operations are performed here, right? The number of operations that are performed because of this nested loop, now that will give me the time complexity. We saw in the couple of examples in the starting also, how many times this operation is getting run. So what I will do, देखते हैं कितना बार ये run हो रहा है. So do you guys agree? How many times does the inner loop run? Can I say that the inner loop run for I times? Can I say this? देखो ना, j equal to 0, j less than I. So can I say that the inner loop runs on I times? Yes. And I, so what will happen? First of all, I will take a value of 0. So when the value of I is 0, this inner loop runs for 0 times. Okay. See, I equal to 0 hai. So j equal to 0, 0 less than 0 is false. So this loop will not run. Okay. Then the value of I will become 1 and this loop will run for 1 times. Okay. Then the value of I will become 2 and this loop will run 2 times. ऐसे करते करते the value of I will become n minus 1 and the inner loop will run for n minus 1 times when the value of I is n minus 1. Okay. So how many total number of times the inner loop has run? Just add up these numbers. Just add up these numbers, right? So it is nothing but 1 plus 2 plus 3 plus 4 plus 5 up till n minus 1. This is the summation, right? And this is nothing but the sum of the first n minus 1 natural numbers. So in maths, we have learned a formula that the sum of the first n natural numbers is n into n plus 1 by 2. So what will be the sum of the first k natural numbers? K into k plus 1 by 2. And what is k for us? I want to find the sum of the first n minus 1 natural numbers. So just replace k with n minus 1 into n minus 1 plus 1 by 2. So it is nothing but n into n minus 1 by 2. So it is big O of n into n minus 1 by 2. These are the number of operations. And if you want to approximate it, you can approximate it to n square. Is this making sense, guys? No, I took into account the end of the first loop, right? See, I have taken into account the outer loop, right? I equal to 0, 1, 2, 3 till n minus 1. And for every value of I know how many times the inner loop will be running. Okay? Cool. So everyone agrees this is big O of n into n minus 1 by 2. And if you want to approximate it, it is big O of n square, right? Okay. See, time and space complexity requires a little bit of maths, but I think this is basic maths, which we all have done in 11, 12 and our times. Okay, cool. Can I move further? Yes. Okay. Let's move further. We'll take more examples only, right? It's better. Okay. Now again, an interesting example is coming, but see, space complexity is not very tough, right? Space complexity, generally, if you make an extra array or something like that, that will consume extra space, right? Yes, you will always get the correct answer using fundamental techniques, but with time, you will see that, you can actually apply shortcuts also, right? Nested loops, n square. Okay. Chat is most disturbing. That is why I think I am shifting to the poll-based method, right? That is much better than looking at the charts because a lot of spam happens in the charts. Okay. 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 Can you help me? Anybody? Can you help me with this? Okay. So people are saying n, somebody is saying log n. Okay. So I don't know anything, right? I want to go and understand via my fundamental method of calculating the number of operations. So let me see how many times is this loop running. Boss, this loop is definitely not running for n times, right? See, let us try to understand what happens in this question, right? How is this loop actually running? So guys, if I want to understand how many times is my loop running, do you agree that first of all, the value of I will be n? First of all, the value of I is n, the loop runs, okay? Then the value of I will become n by 2, the loop runs. Then the value of I will become n by 4, the loop runs. ऐसे करते करते every time the value of I will becoming half, it will be half, right? Then you will get to n by 8, and ऐसे करते करते the value of I will become 1, the loop runs. And then the value of I goes to 0 and the loop does not run. So do you agree? The loop will run first for I equal to n. Then the loop will run again when the value of I is n by 2. Then the loop will run again when the value of it is n by 4. Then the loop will run again when the value of I is n by 8. Likewise, the loop will run till I reach a value of I equal to 1. Do you agree with this statement? सोच के बताओ मेरे को. First, let's say if I is equal to 8 है, okay. So for I equal to 8, the loop will run once. Then I will become 4, the loop will run once. Then I will become 2, the loop will run once. Then I will become 1, the loop will run once. And then the loop will no longer run. So the loop is running for 4 times. See, 1, 2, 3, 4. Do you agree? Take practical example. For I equal to 8, first of all, you will have value of I as 8, loop runs. Then the value of I will become 4, loop runs. Then the value of I becomes 2, loop runs. Then the value of I will become 1, loop runs. So can I say the loop is running for 1, 2, 3, 4 times? Yes. Do you agree with me? And take the value of, just give me 1 second. Yeah, sorry. And take the value of I equal to 16. Okay. How many times will the loop run for I equal to 16? Can you help me? Just one more time, right? 5 times. 5 times. Okay. So I just want to compute how many times is my loop running, right? So first of all, the value of I is n. The loop runs. Okay. ध्यान से देखना. Okay. Then the value of I will become n by 2 raised to 1. Again, the loop runs. Then the value of I will become n by 2 raised to 2. The loop runs. Then the value of I becomes n by 2 raised to 3. The loop runs, right? And let's say after k iterations, okay, see, 1, 2, 3, ऐसे करके हो रहा है. Let's say after k passes, you get n by 2 raised to k. Guys, try to follow. See, I'll just make it once again. First of all, the value of I is n. Then it goes to n by 2 raised to 1. Then it goes to n by 2 raised to 2. Then it goes to n by 2 raised to 3. Then it becomes n by 2 raised to 4. ऐसे करते करते, after k steps, let us see that the value of I will become n by 2 raised to k. And when will we stop? When the value of I will become 1. So if I want to calculate how many times the loop has run here, can anybody tell me? Let's say this is equal to 1. How many times the loop has run here? See, 1, 2, 3, 4, k plus 1. K plus 1 times. Do you all agree? K plus 1 times, dekho. See, this is n by 2 raised to 1, n by 2 raised to 2, n by 2 raised to 3, n by 2 raised to 4, n by 2 raised to 5, till n by 2 raised to k. So these are k blocks, and for I equal to n also the loop is running. So total the loop is running for k plus 1 times. So I just want to find k. Okay. So n by 2 raised to k, this is the last step. Here the value of I will be 1. Okay. So let us equate it to 1. And if I want to find the value of k, what will I do? 2 raised to k is equal to n. Just do a cross multiplication. And now take log on both sides. So k will be equals to log n to the base 2. Okay. So how many times is the loop running? K plus 1. That is log n plus 1. So what is the time complexity? Big O of log n to the base 2 plus 1. I can ignore this constant, and it is big O of log n to the base 2. How many of you have understood this part? देखो भाई, मैं एक बार बताता हूँ. Let me repeat it once again, right? Let me try to repeat it once again. Okay. चलो करते हैं. ठीक है. देखो, मैं क्या बोल रहा हूँ, हो क्या रहा है? First of all, let's take a value of I equal to 16. Okay. So first of all, I equal to 16, the loop runs once. Then the value of I will become 8, loop will again run. Then the value of I will become 4, loop will run. Then the value of I will become 2, loop will run. Then the value of I will become 1, loop will run. Okay, and then the loop will not run. So how many times has the loop run? 1, 2, 3, 4, 5 times. Okay. Now, yes, this is important. You get MCQs, and your interviewers can ask you the time and space complexity, right? And with practice, it will become more and more simple to follow, right? Now, so ho kya rahega guys? Let's say you have taken the value of I as n. Let us try to follow this tree only. What happens? First of all, for I equal to n, the loop runs. Then what will become the value of I? N by 2 raised to 1. N by 2 ho jayega, the loop will run again. Then the value of I will become n by 2 raised to 2. Again, you are divided by 2, right? So it will go to like this, right? Now, again, in the next iteration, the value of I will go to n by 2 raised to 3. ऐसे करते करते you will keep coming down till you get the value of I as 1. Do you agree? This is what is happening, right, for n. Now, what I am telling is, let us assume this is the first step, this is the second step, this is the third step, and let us assume this is the kth step. Okay, this is the first step, second step, third step, and this is the kth steps. So, how many steps are there in total? K plus 1 steps, na? See, this is 1, 2, 3 till k, and this is here one more. So k plus 1 nodes are there. So k plus 1 times the loop has run. Okay. So I just want to compute what is k. Okay. And I am telling you, after k iterations, okay, after k iterations, it has gone to 1. So what is this value actually? N by, dekho, 1 mein n by 2 raised to 1 hua. At 2, you have n by 2 raised to 2. At the third, you have n by 2 raised to 3. So at the kth, you will have n by 2 raised to k. And this is nothing but 1, equated with 1. So now you will find 2 raised to k is equal to n. Take log on both sides. K is equals to log n to the base 2. Okay. So this is the log nth node. This is the log n node. If you start counting from here, and this is one more node. So the total number of times the loop runs is log n plus 1. And you ignore that 1. So it is basically big O of log n to the base 2. Okay. And see, you can get an idea now. What is log 16? 4. Approximately the loop is running for 4 times. Similarly, for 8, log 8 was 3. Okay, so approximately 3 times the loop is running. Okay. Is this making sense, guys? Yes? Kuch nahi karna hai, guys. You start from n, then you get to n by 2 raised to 1. Then the value of I will become n by 2 raised to 2. देखो, मैं मानता हूं कि there are k steps. First n, then you go to n by 2 raised to 1, then you go to n by 2 raised to 2. ऐसे करते करते you reach n by 2 raised to k. And this is the last time that the loop is running, right? So this should be equal to 1. So I just equate n by 2 raised to k equal to 1. And what is k? K will be coming out to be log n to the base 2. Okay. So how many times has the loop run? 1, 2, 3. So these are k nodes here. And this is another time. I equal to n ke liye bhi loop chalega. So the total number of times the loop has run is k plus 1. Okay. That is what is happening. Okay. So log n plus 1. Okay. Why are you taking log? Because we want to find the value of k, right? Bhai dekho na, 1, 2 till k na. So how many steps are there? These are k different steps, right? So I want to find what is k in terms of n, right? That is why. See, if you look at 16, right? You got the 16, then we came to 16 by 2 raised to 1, then we reached to 16 by 2 raised to 2, then we reached to 16 by 2 raised to 3, then we reached to 16 by 2 raised to 4. Okay. So I am computing this. 16 by 2 raised to 4, 2 raised to k is 1. So what is k? K is 4. So these are 1, 2, 3, 4 steps and plus 1. That is why. Okay. How many of you are clear? I am not sure, but let's take a poll. Log is a mathematical function. Okay. Log is a mathematical function. Okay. Cool. So the thumb rule is, अब मैं simple shortcut बताता हूँ. जिनको समझ में आया अच्छी बात है. Try to think once. But the simple shortcut is when you divide something by a number, right? Let's say something like this, right? You are starting from n, going till 1, and every time you are dividing by m. Okay. Then the time complexity turns out to be big O of log n to the base m. Log n to the base m when you divide by m. Okay. So if you are dividing by a variable by m, or you are multiplying every time by m, right? Let's say you have something like this. I starts at 1, I will go up till n, and every time you are multiplying by m, then this is also big O of log n to the base m. Okay. So if you are multiplying by m, or you are, dividing something by m every time, then it is big O of log n to the base m. Okay. Okay. You don't have to memorize, to be very honest, but yeah, if you have to be a little bit good at maths, not very good, but a little bit, you should get understanding, right? Acha, how is this log n to the base m? Agar मेरे को ये समझना हो, see, for I equal to 1, I less than equal to n, and I into is equal to m. Can you guys help me? See, first of all, the value of I will be 1, then it will go to m, then it will go to m square, then it will go to क्या होगा m cube, and let's say after k iterations you stop. After k iterations you stop. So m raised to k should be equal to n. So find out k. K is nothing but log n to the base m. Okay. So k time 1, 2, 3 k times, and for I equal to 1, the loop is running once. So total number of times the loop has run is k plus 1. That is big O of log n to the base m plus 1, which you can approximate it to big O of log n to the base m. Okay. But long story short, if you are multiplying anything by m every time, or you are dividing anything by m every time, then it is log n to the base m. Is it making sense? Solve kiya na, dekho. First of all, I had a value 1, then it went to m raised to 1, then it went to m square, m cube, till m raised to k. And m raised to k should be equal to n. This will be the terminating condition. So find out k. And how many times has the loop run? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 till k plus 1. These are k steps plus 1. Okay. Cool. Let's move ahead. Okay, okay, now I'll ask you one question. Now you will help me. I is equal to n, and while No, we don't care about I being odd or even, right? N being odd or even, we don't care. We don't care about that, right? Can anybody tell me the time complexity of this? Can anybody help me? Log n. Does everyone agree? Log n to the base 2. Same thing, and see what is happening. I is starting from n and getting divided by 2 at every step, reaching till 1. So it is log n to the base 2. Okay, great. Now one more interesting thing, then I think you will be good enough, right? Condition for n log n. बताता हूँ, सब बताता हूँ. So let's say if you have a loop like this. No. See, even if you do a is equals to a plus 2, will it change anything? No, because the number of times the loop is running, it is dependent on I, not on a. Okay, so I पे depend कर रहा है सब कुछ. It will still remain log n to the base 2 only. Okay, अच्छा. Now I am giving you another. Can you help me? Anybody? Anybody? Nested loops, right? What was the thumb rule of nesting? Just multiply. So this loop will run for n times. And what is the time complexity of this loop? How many times it is running? It is running for log n to the base 2. This is log n to the base 2. Multiply kar do, you will get n log n. N log n. Does everyone agree with this? Very simple. Dekh lo na, j starting from 1, every time it is multiplied with 2. So this is log n to the base 2. And the outer loop is running for n times. Just multiply both of them. N log n. Okay. So this is n log n. Now, why base 2? Because you are multiplying j every time with 2, right? You are multiplying j every time with 2. Okay. Now, acha, for your simple thing, what I will do is, see, I have some more questions to take. I will take more questions in tomorrow's class. But let's do some practice questions from Geek for Geek, so that at least you are clear with what we are learning. Is it making sense or not, right? Chalo. Up guys, you will help me with the answers, right? We will try to solve questions from here now. Okay. What log actually do? Log is just a mathematical function, right? If you are multiplying I with 2, then also it is log n to the base 2. Okay. Acha. See, this is pseudocode, right? This is pseudocode, right? This is pseudocode. Okay. This is pseudocode. Okay. अब लिंक मैं बाद में शेयर करूंगा. Let us try to solve these problems in class so that I will be able to understand what is the understanding that you have gained, right? Acha. Can anybody help me? What is the time and space complexity of this code? Anybody, can you help me? Option number batao. What is the option number that is correct? Option number 3, right? Option number 3 is correct. Why? See guys, these two loops are not rested, right? So this is running for n times and this is running for m times. So what is the time complexity? Big O of n plus m. Okay. So two options have been eliminated. Now what is the space complexity? Have you made any extra array or anything like that? All are basic variables. Okay. So the space is independent of n. So it is big O of 1 space complexity. So the correct answer is option number 3, big O of n plus m time and big O of 1 space. Is everyone clear with this? We will quickly solve 10 questions in 10 minutes. All are basic questions, right? Space समझ में आ रहा है? Big O of 1 space complexity. See, are you making any extra data structure? Are you making any extra space? No. These are all the basic variables, right? Even if you increase the value of n now, the space taken by the program will not change. That is why the space complexity is constant, big O of 1. Okay. It is not dependent on n, right? You are only 4 variables. Hai na mere paas. See, what are the 4 variables in this question? A, B, I, and n and m, right? So if n is 1000, 10,000, 20,000, right? Still you are using the space for storing 5 variables, right? Big O of 1 means it is constant. It is independent of input, independent of n. Okay. No, we use always big O notation. Okay. Okay. Let's move. सबको समझ आया? Can I move further? How to know big O of 1? Guys, simple rule will be, are you making any extra array or any extra data structure? No. So it is big O of 1. Another way to understand is, you just have primitive variables. So irrespective of whether n is 100,000, 10,000, 1 lakh, the amount of space that you reserve, that will be constant, right? 4 bytes only. 4 into 4 into 4 into 4 into 5, right? 20 bytes only. So that will not change. That is why it is constant space. Now let's move to the next question. Dekho, since the variable size does not depend on the size of the input, right? If input is 100,000, 10,000, the variable size will be fixed, 4 bytes or 2 bytes, whatever, right? Therefore, the space complexity will be constant or big O of 1. Okay. Now, let us come to the next question. Okay. Let's look at this code. Can anybody help me? Let's look at the options. So what is happening? N square. So we see 2 nested loops. So you are saying n square, right? Okay, good enough. Not bad. Where did my pen go? Yeah. But if I want to be extra sure, if I just want to be extra sure, how can I be extra sure? When the value of I is 0, how many times is the inner loop running? Can you tell me? When the value of I is 0, how many times is the inner loop running? N times. Dekho, n times na. J will start from n and go all the way till 1. Okay. So n minus 1, n minus 2, n minus 3 till 1. So n times. Then when the value of I will become 1, the inner loop will run for n minus 1 times. ऐसे करते करते, when the value of I will become n minus 1, how many times will the inner loop run? Can anybody help me? 1 time only. Only 1 time. So if you add all these things, what is it? It is the sum of the first n natural numbers. So it is n into n plus 1 by 2. This is nothing but n square. So option number 4 is correct. Is it making sense? The fundamental way of analysis? Yes? Okay, great. Kuch nahi karna hai, guys. If you understand how many times the loop is running, your job is done. As simple as that. Okay. Let's come to the next question. N square hai. Dekh lo, inhone bhi yahi kiya hai. They have computed how many times this is running, right? Okay. So it is n into n plus 1 by 2, which is n square. Now let us look at this code. Can you help me? I think we have discussed this just now. कैसे करेंगे? Let us try to understand. How many times is this loop running? N by 2 times. How many times this loop is running? Log n to the base 2. Okay. So multiply kar do. It is n by 2 log n to the base 2. Drop the constants. It is n log n. N log n to the base 2. Okay. Simple. Let us look at the answers. So we are saying option number 2. Let us see. Option number 2 is correct. Okay. And explanation you can read later if you want. But yes. Okay. Now, what does it mean when we say that an algorithm X is asymptotically more efficient than Y? What does it mean, guys? Let us take options. Okay. Can you tell me? When I say that, boss, an algorithm X is asymptotically better than algorithm Y, what do I want to say? That X will always be a better choice for large inputs, right? For small inputs, we cannot say. Guys, whenever I talk of the big O notation or omega notation or theta notation, right? We talk about large values of input, right? Okay. At small values of inputs, they, n square might be better than n or something like that, right? So when I say that an algorithm is asymptotically more efficient, that means that X is a better choice for large values of n, for large inputs, right? There will be a certain point after which X will always be better. So option number 2 is correct. Okay, option number 2. ठीक है? Explanation बाद में पढ़ना आप लोग. Now, let us come to question number 5. Okay. I am just trying to make you guys, give a flavor of what type of questions get asked, right? Again, what is this code? Can anybody help me? The time complexity. Simple, very simple. क्या है? Log n. What base? Base will be 2. देख लेते हैं. So option में log n है. So we'll go to 4 log n. Okay, it's log n. Correct. No. How option number 3? How? See, I greater than 0 and you are dividing I by 2 every time. So it is log n, right? Log n to the base 2. Option number 4. Okay, great. Okay. 6 is very simple question. ये समझ नहीं आया. Why, Kambir? I is starting from n and every time I is getting divided by 2, right? So it is the same thing. The n say n by 2, then n by 4, then n by 8, n by 16. ऐसे करते करते it will go till 0 or 1, whatever, wherever it is stopping. It is log n. Okay. What is the best criterion or useful criterion for comparing the efficiency of algorithms? Both time and memory are important. Both time and space are important. So I will go with option number 3. Both of the above. देख लेते हैं भाई, both of the above. Great. Okay. Now, how is time complexity measured? How are we measuring time complexity? देखो तो भाई. By counting the number of algorithms in algorithms? Definitely no. By counting the number of primitive operations performed by an algorithm? Yes. What were we doing? We were counting how many primitive operations or how many operations are basically performed for a given value of n. Okay. We don't count the size of the data, right? We see that as I change the input, how is the number of operations changing? So option number 2 is correct. By counting, because the number of operations that you perform, that will directly affect your time. So option number 2, देख लो, by counting the number of primitive operations. Okay. Let us come to the C++ करते हैं अभी. What will be the time complexity of the following code? Can anybody help me? Again, very simple. Log n. And what will be the base, guys? Can you help me with the base? Log n का base क्या होगा? Base k. Okay, great. Very good. No, not 2. This time I is getting multiplied with k every time. So it is log n to the base k. देख लेते options. See, this time to confuse you, you have 2 options. Log n to the base k, log k to the base n. So answer will be log n to the base k. Option number 3. Let us see. Answer is option number 3. Again, I have already explained this thing. Okay. Let's come to question number 9. Okay. Acha guys, let us see. Seems like it is nested hai. But option number 1 and 2 I can eliminate, right? But what from option number 3 and 4, what will you choose? Chalo dekhte hain. Just go to your fundamental calculation approach. You will see what the answer will be. Go to your fundamental calculation approach. What happens? The inner loop is running for I times, right? So when I equal to 0, jab I ka value 0 hoga, how many times the inner loop runs? 0 times. Then the value of I will become 1. How many times the inner loop runs? 1 time. ऐसे करते करते I will take a value of n minus 1 and the inner loop will run for n minus 1 times. So how many operations are performed? 1 plus 2 plus 3 plus 4 till n minus 1. And what is the sum of the first n minus 1 natural numbers? It is n into n minus 1 by 2. And what have they done is they have dropped the constant. So if I have to choose an answer, I will choose n into n minus 1 because this is nearest to my answer. Option number 3. Let us check it. N into n minus 1. Okay? Let me clean it up. Let's come to question number 10. Answer ही दिखा दिया. Okay. So algorithm A and B have worst case running time of big O of n and big O of log n. Can you say that algorithm B always runs faster than algorithm A? Answer दिख गया. ठीक है, logically सोचो. If I say big O of n and big O of log n, can you always say that big O of n is better than log n? No. I can only say that big O of log n is better than big O of n at large values of n. So it will be false, right? देखो क्या लिखा है. The big O notation provides asymptotic comparison. That is, we are looking at large values of n. So for some value of n that is lesser than n naught, algorithm A might run faster than B. Okay, for small values of n, n might prove to be faster than log n. But as I increase the value of n, right? Now see, जिसको graph अच्छे से समझेगा ना, the people who are comfortable with graphs, you will be able to relate better, right? At small values of n, right? If you talk of small values of n, how does log n look like? How does log n look? Log n looks like this. I am not sure. I am not very sure, but yeah, this is how the log n graph looks like, right? So what I am telling is, ऐसा कुछ सोचो, I am not sure, right? At small values, na, see, this is just two graphs that I have drawn, right? But what it is telling is, whenever I talk of asymptotic notations, now we are talking about large values of n, right? So as large values of n, now you will see that log n is always better than n. But there might be some points like this. I'm just drawing something, right? I'm just drawing. I am not sure. I'm just see. What I am telling is, if you have two graphs like this, right? If you have two graphs like this, for small values of n, let us say this point is x. Less than x, this algorithm is better. Greater than x, this algorithm is better, right? So asymptotically, I will say this algorithm is better. Asymptotically, right? Because for large values of n, this algorithm proves to be better. If this is the time axis and this is the input axis. Are you getting what I'm trying to say? So whenever I talk of big O notations, we are talking of large values of n, not for small values of n. Because for small values of n, everything can be comparable, right? Cool. So 6 minutes are left. Let me get a pseudo poll. Okay. Create a poll. MCQ. I'll just get. See, in question number 9, I have taken the effect of the outer for loop. Gaurang, if you try to understand, just 1 second. I just want to get an idea how many of you are at least somewhat clear. Yes or no. Okay. And just mark a yes if you are 70 to 80% clear, right? Because this topic is a little bit tricky. So the first time when you do it, definitely it is like a little bit, how do I share the link? Yes. Okay, guys. Just because I explain, I'll just want you all to fill up the poll once again so that I get an idea of where we are going with the class flow, right? Tomorrow we will spend 1 more hour on time and space complexity and try to take up some more questions, right? So that we are more clear and we explore something also. But with this idea and with the problems that we have solved today, I am pretty sure you must be getting a decent idea of what type of questions will be asked here and how do you actually estimate these things, right? Share some questions, right? I'll share some questions. Okay, I'll share some questions. अच्छा, जो पूछ रहा था n into n minus 1 कैसे? I have taken the outer loop into account, right? For I equal to 0, the inner loop was running for, let's say, 0 times, right? For I equal to 1, the inner loop was running for 1 time. So ये I का जो अलग-अलग value ले रहा हूँ, that is simulating the outer loop, right? कहाँ से पोल देना है? Here a link. I'm sharing the link in chat. Okay. How many days module 1? So Tarun, ideally we are looking to wrap up. We are looking to actually get done with the contents of module 1 by 25th or 26th, right? And then you will get a few days of gap, like 4 days of your self-study and practice, and then you will give the module test. That is the thing that, right? I'll share some more questions, right? Interview bit where you have good questions, right? On interview bit. On Geek for Geeks also, you can take some other questions, right? Sir, what if the node is used as a data type, then what will happen to the space complexity? No. See, we are interested only in the variation with n, right? I am not 3n and 6n. You are correct that 6n is greater than 3n. But in big O notation, we just want to give an idea of how is the time actually varying with input, right? Okay. Okay, guys. Cool. So I'll ask you all to revise the concepts that we have discussed today, especially the log concept, right? And people who have understood it, please try to explain to your friends also so that they are also, better understanding the things that we are discussing. And tomorrow, what we will do, 1 more hour, we will solve more questions on this. Okay, only questions we will solve. 1 more hour will be sufficient to cover this topic. It is not that difficult, right? And then we will start up with sorting or recursion. Okay, so tomorrow's class is also dedicated half for time and space complexity, and then we will try to pick up a new topic. Okay. Yes, we will have classes on Saturday and Sunday as well, so don't worry, right? I'll take more number of classes so that people are clear with the concepts. Okay. But yeah, was the pace today fine? I think the pace was fine today because we just did how to analyze different codes, right? Was the pace fine for everyone? यार एक झट से इसका भी पोल बना देते हैं. So I just get an idea. Recursion is a little bit difficult topic for sure. We will have 3 classes, 3 entire dedicated sessions on recursion, right? Okay. Can you get this poll here? Okay. No नहीं रखा क्या? Oh wow. What have I done? Just 1 sec, guys. अरे भाई क्या हो गया? Okay, sorry guys. No more polls. Okay. Anyways, okay. So let's meet tomorrow, guys. We'll start with we will try to take up some more questions so that you are clear, right? And I will introduce you to some trick questions, right? He nested for loop hai, but it is not big O of n square. We'll try to take up those questions tomorrow. Okay. Cool. Hello, guys. Okay. Good night. And yeah, try to revise the questions that we have done today. Try to see whether you understand things. Try to focus more on the log n wala concept, right? How are we getting that log n to the base m? See that? Once you are clear with that, most of the things will be clear. Okay. Chalo guys, good night. Let's meet tomorrow then. Chalo, bye-bye.